These days, it takes longer to get a mechanic's license than a pilot's license.
24 hours a day, someone is here managing all of this.
We have about 120 pilots in our company and around 80 mechanics. There used to be something called air ambulance service. There were bases scattered all over Poland.
Safety wiring is one of the basic tasks of an aircraft mechanic. How much do you earn in this job? What are the rates and what do they depend on?
In Poland, an aircraft mechanic is able to earn more than...
So let's get started. In one of the episodes, my friends, on the Duro Body channel, we were flying helicopters and today we're going to service them. I'm here with Kuba. Great to have you here.
Hi, Wojtek.
What is this beautiful place and what are these machines?
We are currently in the Technical Service Station, or the SOC, of the Air Ambulance Service, a maintenance organization where we repair and service these beautiful helicopters. In Poland, we have 3 SOTs, which are Technical Service Stations. One is right here in Warsaw, the second one is in Goleniów near Szczecin, and we also have a third SOT, which is not strictly for helicopters but for airplanes, and it's located nearby at Okęcie. In total, we have 27 helicopters of this type, the EC-135 in Poland. In Poland, yes. Besides that, in the airplane team at Okęcie, we have 2 Learjet 75 planes. They mostly perform scheduled domestic transports, but also international ones.
Okay, here we have, as you can see, 4, actually 3 helicopters disassembled. Yes, you could say laid out.
One is fully assembled, because this one will soon be performing flights, training flights. Here, our fellow pilots are already getting ready. In a moment, we'll be taking it out and it will be flying so our pilots can train.
Speaking of you, since we talked recently, it's really nice that I'm here and that we can talk. Who are you and what do you do here?
I'm an aircraft mechanic. I also suspect that not many people know that aircraft mechanics also have their own licenses. I have a B13 license, which is for helicopters with turbine engines, but I also have a B14 license, which is for helicopters with piston engines. You might know the Robinson R44, though I'm not sure if you've flown it.
We flew it in the episode with Marcia.
Who was, yes, I am also a licensed mechanic for this type of helicopter. In October, it will be 7 years since I started working in air ambulance services.
A tremendous amount of knowledge, so be sure to stay until the end because this episode is going to be really interesting. We're looking around and of course getting to work.
Usually everywhere in the world, this helicopter, the EC-135, is transported using transport wheels and a tow bar. But for our needs, this device was created, which allows us to move the helicopter in and out much faster and more efficiently.
All helicopters, and as you mentioned, there are 27 in Poland. When they need to go through service, they have to fly here, for example, to...
Yes, here to Goleniów, yes. There are situations when the malfunction is so serious that the helicopter can't actually fly to us. So then a flatbed truck is ordered, a big truck with a hydraulic crane, yes. And then the helicopter is simply transported on its wheels, yes. The blades are removed. Of course, there's a special procedure for transporting such a helicopter by road. So we go there, disassemble the helicopter, load it onto the truck, and then it comes here to us.
Helicopters must rarely break down since I've never seen one on a tow truck or wheels.
Rarely, it really is rare that it has to come to us by land. Usually we go to the location, whether it's a malfunction in the field or a bigger issue at the base. We try to handle it at the base so that transporting it is really a last resort.
Okay, so we can also provide service by going to the customer. Yes. Since we have a fully operational helicopter here that's about to take off, maybe you could say a few words about this equipment. Later, we'll look at the disassembled ones, which will be fascinating. The precision in those turbines and components is amazing, so I'm excited for this episode. But since we still have this equipment here in this color scheme, we can talk about it.
Sure. So just as a reminder, this is a Eurocopter EC-135 helicopter from 2010. A service bulletin was also carried out on this helicopter. You could say a kind of facelift of the helicopter to the P3 standard.
Who fits in a helicopter like this?
In this version, we have the training configuration. So we have 2 pilots here. So we have 2 control sticks, 2 sets of controls, because this is a training configuration, so it was for 2 pilots. But generally, when these helicopters fly in HEMS, our commander, meaning our pilot, sits in the front right seat. On the left side, we have the paramedic, who we call Jack, meaning a member of the HEMS crew. And here in the back on this seat sits the doctor. The other seat isn't there. There's only a stretcher there for the patient.
People always have to adapt in every situation, and here you can't just add someone to this crew, right?
No, you can't. I mean, of course, when you're flying to an incident, it's rare that it's only our crew, right? There are usually some other ground teams there as well. But quite often, our helicopter is the first to arrive at the scene, so the two of them really have to handle the medical emergency on their own, because the pilot's main task is to take care of the helicopter. If we land somewhere in an unprepared location, then the paramedic and the doctor go to provide assistance. And the pilot has to stay around the helicopter, making sure it's safe so that no bystander comes close and damages the helicopter.
Okay, so we have two people who are saving lives. Well, ladies and gentlemen, you can imagine how big Poland is, how many people live here, how many accidents and bad situations can happen, and we have only 27 of these helicopters in Poland.
Yes, yes.
Yes, and is that 27 including the ones serviced here?
Yes. So it holds. We have
Currently turned off.
We have 21 such permanent bases. We also have one seasonal base in Koszalin, which is open during the summer season, let's say, to support that region of Pomerania. I believe that by the end of 2028, the base in Koszalin will be operational year-round.
So all of this is state-owned, not private companies, right?
Service companies? No, it's all basically a state-owned company.
You work for the state too, right? Yes, even as a service technician, you're part of the state company, yes.
The air ambulance service is under the Ministry of Health.
Okay, so we'll wait a little longer until the helicopter takes off. We'll see it in flight, and in a moment we'll go back into the hangar and you'll see what these helicopters look like taken apart into their basic components. So the gentlemen are about to take off. Will this be a training or a test flight? How does it work?
Well, in this case, it will be a sort of refresher flight. Every pilot has to go through a training or check flight, so that's exactly what's happening right now.
Maybe the viewers would like to see an episode where I do this kind of flight with an instructor pilot or with a rescue aviation instructor, for example. If so, write in the comments and maybe we'll be able to make it happen. If there are many comments, the air ambulance service will agree to a video like that. For now, I'm focusing on making a video about the mechanics. Do you, as mechanics, also have a license to fly aircraft like these, or not necessarily?
Not necessarily. I personally don't have one. Of course, there are mechanics who also have a pilot's license, but in our case, it's not required. Of course, it happens that we take part in post-maintenance flights quite often. We have to perform a technical flight like that to check all the systems. So in that case, we actually take part in that test flight, but not as a pilot, just as the technical person on board who checks all the flight parameters using various devices.
And at the beginning of the episode, you mentioned some licenses for two types of helicopters. Is that a license to be able to service them?
Yes, that's right. Like I said, I have a B 1.3 license, but just having the bare license doesn't really authorize me to do anything yet, right? We still have to get type training, which means training for the type, so training for a specific aircraft, right? In order to service it, but only that specific aircraft, right? Even though
it's like being a car mechanic, that you're a mechanic, I don't know, you finish technical school and you can repair any car model.
No. I mean, of course I can as a trainee in the sense that I can work under someone who has a license and I can gain experience, but to be a fully qualified mechanic, meaning to certify my own work, unfortunately I can't do that yet. I can only work on those types that I have training and certification for.
How long will such a flight take? What does that involve?
It's about 2 hours, according to what the guy said.
Yeah, two of them were flying, testing it. All right, let's take off. Here behind us is probably the most disassembled helicopter in this whole hall. What happened here that you had to take it apart like that?
Yes, this helicopter is very disassembled. We found a structural crack on the tail boom. And unfortunately, repairing something like this is not within our jurisdiction, so the entire boom had to be sent back to Germany to the manufacturer. And that's why we had to remove the boom. But let me tell you an interesting fact. You actually came to us at the perfect moment, because removing a boom like this happens on average once every 5 years.
Here's another reason to watch until the end. We're by this equipment. What can we say about it? What do we have here? These are the turbines, the engines, right?
Yes, here we have exactly two, as you can see, two engines, so-called turbo shafts. In terms of construction and operation, they are similar to the engines we have in passenger airplanes, except here the exhaust gases don't provide thrust, but instead drive a free turbine. The free turbine drives the shaft, which isn't here right now. But here is the shaft, and it comes out of the engine and goes into the gearbox. The gearbox is like a transmission. You can compare it to cars. The gearbox transfers power from the engine to the main mast, so it drives the blade, but also to the tail boom and the tail rotor, which we don't have here right now, right?
I'm almost afraid to ask if I'll even be able to do anything here. For now, I opened the gate, but I'd really like to help you with all of this. But looking at this complicated theory you're talking about, I'm afraid it might be tough.
Yes, that's also related to the fact that aviation is all about procedures, right? And for example, for you, even as an intern, to be able to do anything with the helicopter, I don't know, hold something, I don't know, unscrew a bolt, even under my supervision. You still have to undergo our internal training on health and safety regulations, on procedures, basically on how to move around here in the hangar. So unfortunately, you won't be able to do anything today directly on a real aircraft. But we also have a surprise prepared for you for this occasion. Later in the video, we'll have something special for you.
All right, let's move on so we can get something done. There's not much you can do since this equipment is all taken apart. Just to follow up, let's say you sent the back part to the service center. So why is it still all taken apart here?
Here, helicopters undergo what is called heavy maintenance when they arrive. We distinguish between annual maintenance, meaning once a year a helicopter comes to us, we take it all apart, check the components that are here as required by the procedure. And that's basically the main type of heavy maintenance, the annual work. But we also have something called periodical maintenance. That's once every 3 years. So when the helicopter comes to us, then we also take it apart. But then it's really a thorough inspection, you could say the most comprehensive one. This helicopter is currently undergoing its 3-year maintenance check. We have to check all the components and the structure one by one, just to make sure the helicopter is airworthy and safe, so that everything in it is in order.
How long does such a service take?
Let's say, I don't know, from 3 weeks to a month for the simpler yearly maintenance, because there are a bit fewer tasks to do. For the 3-year maintenance check, it takes up to a month and a half.
Since Poland has 27 machines and a year has 12 months, you'll always have work.
We always have work to do. There's never a situation where we have, I don't know, a week of downtime with absolutely nothing to do, right?
Looking around the hall, I've counted about 10 or 15 people working here. Who are these employees? I see both young workers and some older, more experienced ones.
What didn't I mention at the beginning that I should have? Aviation, and especially aircraft mechanics, is very much a team sport. Most of the time we either do things together, or if there's a problem we're trying to solve, we always work on it together and share our experiences. Everyone here is very, very important, but in reality you can distinguish 3 types of aircraft mechanics. A trainee mechanic is a person who doesn't have the qualifications or a license and can't perform tasks on the helicopter independently or certify them. We have a licensed Category B mechanic, like myself, who can already perform tasks independently, certify their own work, and also certify and supervise the work of trainee mechanics. But we also have something called a lead mechanic. The lead mechanic has a Category C license and is authorized to close and issue certificates of release to service, which means confirming the aircraft's readiness for flight after maintenance. And that's exactly what a lead mechanic does. Not only does he supervise the work of the mechanics on the helicopter and assign them specific tasks, but at the end he also issues the CRS, which allows the helicopter to fly and participate in missions.
Maybe we should go to the lead mechanic, and after all, he might give me a task that we can carry out.
Hi, Adrian.
Hi, Kuba. Hi, Wojtek.
Hi, welcome. Let's move the microphone closer here so we can see what we're going to do, what tasks we have from the lead mechanic.
So for today, since the work on DXD is slowly coming to an end, we'll install the main rotor blades. It's quite an interesting task. We have a strong team here, so we'll definitely manage.
So teamwork, just like you said.
It is.
Let's get to work. There's no point in waiting here. You have all these plans here too. I saw them written out, action plans, some instructions and so on. How do you know what you're supposed to do today and what you'll be doing tomorrow or next week?
Generally, when it comes to all the maintenance orders and specific tasks, the Continuing Airworthiness Management Department issues them, and we perform the maintenance exactly according to those orders. We, the supervisors, try to determine the order of individual tasks so that people don't get in each other's way and the maintenance goes smoothly.
And when we pulled you away from this little desk, is it usually here at this desk where the supervisor sits and plans these activities, or do you also work hands-on here too?
Well, generally I'm a person who has a lot of energy, so as soon as I finish my paperwork here, so to speak, I go turn some wrenches, because I miss that.
Let's not hold you back. Let's go turn some wrenches.
Right.
Very much a team effort, I have to say. Everyone knew what they had to do, but still some commands had to be given and followed. Each propeller here is a different color.
Let me correct you. We have a propeller on a plane. Here we have blades. Each blade has a different color. Here a dot. This is mainly related to the tracking of the main rotor blades. Because we have a rotating mass here, we need to balance it. So this is for identifying the blades, but besides balancing so the main rotor doesn't vibrate, we also need to make sure that all 4 blades follow the same path. And that's why we need identification. A colored blade, so for example, the computer we connect, which analyzes the data, tells us that, for instance, the blue blade needs to have its push rod either lengthened or shortened by a quarter of a turn, right?
We rely on the computer for everything. We don't judge by eye here.
No. I mean, back in the day, I can tell you this is an interesting fact, before all these modern computers that help us so much now. We used a tracking method basically when we started up the helicopter. We used to paint the tips of the blades with a paste, an oil crayon, and you would just approach with a stick, a piece of paper, and hold it up to the blade, to the spinning rotor. You would hold the stick up, okay? And then, yes, and then you could see, for example, the blue one left a mark showing it was higher, the yellow one showed it was lower, and based on that, the track was set. Today we do it differently.
It was dumb, but it worked, so no?
Well, of course, but here we have a slightly less drastic method.
Since we're already talking about this equipment, there are a lot of things here that interest me, from the brake disc and Brembo calipers to the flex lines that are bolted on here. So maybe a few words for our viewers about what's here, because it's really interesting.
Right, let's start with the brake disc. Since our helicopters fly into rough terrain to reach the patient, and it's safest to approach the helicopter, once the rotor is stopped, that's why our helicopters have this braking system, simply to shorten the time it takes for the main rotor to stop. Okay. Yes, because everything is connected rigidly, as I mentioned. We don't have the drive shafts here, but this is where the drive shafts go. From the engines. Yes, from both engines they go into the gearbox, and the gearbox, as the name suggests, transfers the power here to the main rotor.
Do both engines need to run, or can you fly with just one engine and still operate this rotor the same way?
Yes, it is possible that if one engine stops working, you can continue flying, and I suspect that in that case you just need to find a place to land as soon as possible and land yes.
I'm very interested in those flexes.
The flexes are there because we have hydraulic pumps on the left and right sides. The hydraulic pumps are there because that's basically our power assist. Because there are a lot of forces involved in controlling this helicopter, that's why a hydraulic system is implemented here, which assists all the pilot's inputs. And why is there a flex here? It's because if we want the pump to work, the pump is driven by the gearbox. So for pressure to be generated in the hydraulic pump, the helicopter has to be running so that the gearbox is turning. And it's rather hard to do that in the hangar, so that's why we have a kind of special adapter here into which we put the hydraulic pump, and it lets us run the hydraulic system without running the helicopter if needed.
It's been added, this element has been added, right?
It's only used during maintenance, like I said.
But this entire element, these, right?
I mean, this is permanent and only this flex goes in here. All right.
It's not there when the helicopter is flying?
Then it's not there. No. Then the pump is directly connected, the drive goes into the gearbox, and the pump is permanently attached here. Later, we'll also show you, once the push rods are installed, we'll do everything, because we also have to perform a hydraulic leak test. We'll also connect these grinders, as we commonly call them, and we'll also be able to show exactly how the whole helicopter control system works here.
Here we also have some radiators.
Yes, we have radiators here on the left and right sides. These coolers are obviously there to cool both the gearbox oil and the engine oil, right?
It's still super interesting, really interesting. Let's move on, because there's still more to talk about, and the video is still going, and it's great that you're watching this. Be sure to leave a thumbs up under this episode so this information can spread even wider across the whole internet. Kuba explains this really well, so others should watch too. Please leave a thumbs up for me, Kuba, and the Do Roboti channel. It's cool here because we have 3 machines, each with a different service, so we can discuss them separately. This is also the shaft where we just inserted the blades, right?
Exactly. We commonly call it the mast. It goes into the main gearbox, and it's the main gearbox that drives the main rotor. Well, some kind of maintenance had to be done here. That's why it's taken out. I'll tell you an interesting fact too. Removing this shaft isn't common either. We took it out about 1.5 or 2 years ago, so you caught it at the perfect time.
Well, this is the Do Roboty channel. Here you'll find only the best bits, only good stuff on this channel, so it's worth following and subscribing to this channel to catch episodes like this. Let's move on. I also have a question about the employees who work here. Is everyone trained for every type of service work, or are there, I don't know, people assigned to specific tasks, like some only do doors, some do mechanics, some do, I don't know, something with the bodywork and so on?
The main division here is actually between mechanics and avionics specialists. A mechanic obviously handles the mechanical stuff, while an avionics specialist is actually responsible for the electrical systems on the helicopter, meaning all the systems. Is that right?
Looking at it from that perspective,
As you can see, there are a lot of cables and quite a few systems. We also have specialists for composite repairs. Later, we'll go to the WNK, which is the composite repair workshop. There, you could say, are craftsmen who handle repairs, whether it's composites or some sheet metal parts. And we can also assign a subgroup specifically for servicing blades. Basic maintenance on those blades can be done by any mechanic with a B license, so I can perform that kind of maintenance. But when we need to perform more advanced work on the blades, then proper training is required, for example, to replace those trim tabs. So that can't be done by just an ordinary mechanic. It has to be someone who has been trained by the manufacturer specifically for the blades. And then only that person is allowed to work on the blades.
but the amount of knowledge required for servicing in general, you mentioned there are 3 or 2 subgroups, so what exactly does a mechanic really need to know? Servicing, replacing, repairing each component, potential issues, and diagnosing problems.
Yes.
God, but this is,
for me, a whole life of learning. Yes, knowledge, just the experience itself, that's also important. But really, the foundation when it comes to working as an aircraft mechanic is working with documentation. Each aircraft manufacturer gives us technical documentation. How many pages does it have? I can't tell you here because at ECK we actually have it in an app, you could say, but when it comes to the Robinson R44, the manual there has about 1,200 pages. Being a mechanic isn't about memorizing tasks, since that approach doesn't work. You need to find the task, the right procedure, read it carefully, and then perform the maintenance according to that procedure. In reality, it's not just pilots who need English, but also mechanics, because actually 99% of the manuals or maintenance documentation for aircraft, whether it's for this one or others, is in English. I personally am also a graduate of an aviation technical school, and in that aviation technical school I had a subject called aviation English.
I'll discuss how to become a mechanic soon, but I just thought of something. When we take a car to a mechanic, they look for the problem, might or might not find it, replace a part, ask us to test it, and if it fails, try another part. So where does your knowledge come from, for example, to make a diagnosis when a pilot comes in and says something isn't working or he heard a noise like a knock?
For us, it's actually a bit easier because we have the manual, the database, right, where we can get the information from. Most aircraft manufacturers include something called troubleshooting in their manuals. So when a fault occurs or a symptom of a fault appears, we have guidance. If, I don't know, a warning light for X comes on, for example, then you should check this, and that, because that's what could have caused it, right? Also, the most important thing is talking to the pilot, because it's usually the pilot who reports the fault to us. So the key is really talking to the pilot to understand exactly what happened, and that makes it easier for us to get to the bottom of the issue and solve the mystery, you could say.
So, to wrap up this topic, how does one become a mechanic like that? What does the path look like to end up here servicing these helicopters?
I'll say something else, maybe a controversial theory, maybe not. It seems to me that nowadays it takes more time to get a mechanic's license than a pilot's license. This is, of course, related to gaining experience, but the regulations themselves also really limit us. To become an aircraft mechanic of the category I am, B13, you have to work as an apprentice in the maintenance environment for at least 3 years.
To become an apprentice?
I mean, no, to become an apprentice, you can do that right away, just like that. You don't need any
Technical school and the like?
I'll talk about technical school in a moment. It's the technical school that reduces the internship period needed for the license, because normally if someone comes after high school, the time to get the license isn't 3 years, but 5 years. Here's an interesting fact, since you're a graduate of an electronics technical school, if I'm not mistaken. The regulation also mentions not only aviation technicians, but also your profession, from what I've read. So you could actually become a licensed mechanic after 3 years as well, not 5.
So after 3 years, I become a licensed mechanic and then I already work as a mechanic.
Yes, yes, yes. Of course, you still have to complete a few different courses along the way. Mainly, these are modules of general knowledge, like aviation knowledge, but also personalized ones. You have to pass about 10 to 12 of these modules. During these 3 years of practice, you also have to learn these modules along the way. Once we've passed the modules, then we have to do the type training. Once we have the type training, 3 years of practice, and the modules passed, only then can we apply to the Civil Aviation Authority for our license. So this path, well, it's not that simple, I would say.
If this information has already scared you, it might get more complicated, but it's worth hearing them all. Are these internships paid, meaning does someone earn money while doing them, or do they have to pay for them like for a training course?
I mean, you have to make a distinction here because a trainee mechanic isn't just someone who comes in for an internship. We also get interns from technical aviation schools who might be here for a month and come once a week. We're talking about the 3-year track, but that's basically as an employee, just their status. Of course, it varies from company to company, but here we call it a trainee mechanic, someone training for their license to get their license. But that's it. He works normally, yes, he earns a salary, he's on an employment contract, at least here it's an employment contract, and he works, and he gains experience, yes, yes.
He also has to pass those courses, and if he doesn't, he probably gets let go because he's not suited for the job. Altogether, here in this service center in Warsaw, how many people work here?
I think around 25 or 30, yes. Of course, it's also worth mentioning that we work in 3 shifts. We haven't mentioned that yet. The first shift, which is from 8 to 4, that's the one we're on today. It's obvious that a person's productivity is highest during the day, so most of the work gets done during the day on this first shift. The second shift, you could say, is kind of like a field shift. Because, for example, if we have a defect at a base somewhere in Poland that can be postponed, since the regulations allow us to do that, we postpone it and take action after the shift is over. Well, most bases operate until 8 o'clock p.m. So when the second shift comes in, which works from 4 o'clock p.m. to midnight, it's during this shift that there's a trip to the base to service the helicopter, right? And we also have a night shift from midnight to 8 o'clock a.m., but that's strictly just an on-call duty.
Great, so where are we headed now? I'd like to show you something next.
I wanted to show, yes, because of course a hangar is a hangar, but a hangar would really be nothing without the warehouse where we get our parts from. So I think now we'll go to the warehouse and talk a bit about it there.
Come with us. Now we are in Adam's Kingdom. Welcome. Hi. This is the high bay warehouse. Do you have all the parts needed for servicing here? How does it work?
Generally, these are small items. The so-called standard parts like washers, cotter pins, and screws. But sometimes you also find things like pilot seats and bigger items like a gearbox or an engine, which is the main part of a helicopter.
But do you order them for a specific service, like when you know something is broken and you're going to fix it, so you have to bring it here? Or for example, like I see over there, maybe a fuel tank, some rotors and things like that. Do they just sit here and wait in case something breaks so you can replace it? It looks like...
Basically, if there's a malfunction somewhere out in the field, we have spare parts in stock. It's planned that 3 engines or 2 blades or the main rotor are regularly replenished. And for small items, we buy 200 or 300 pieces in advance, so these are minor elements that have to be available at all times.
Okay, so you're well supplied. Behind us, there are some interesting machines that you probably don't often see in internal warehouses. What kind of machines are these?
Yes, this is what's called an automatic storage rack. The idea is that we don't need racks as big as the ones upstairs. Everything is stored here in drawers, as you can see, which are moved automatically. At any time, we can pull out a specific drawer where a particular part is located. First, this means we need less space to store these parts, and second, it's faster to operate. I don't have to search through shelves like in a standard warehouse.
For example, you could type that you're looking for a specific washer.
Measure.
Okay.
And each drawer contains about 15 bins. Every item is labeled separately. If we run out of stock, we order more items.
How many drawers are here?
Each machine contains 35 drawers and each one is currently filled. At any time, we can start this machine, take out a specific part and send a mechanic anywhere in Poland to deal with a fault.
So we take the parts here and then move on to the service. Helicopter service is not just the manual work we showed downstairs, but also work on the computer, as you can see. With me is Rafal. Hello and welcome. What happens here in your office?
Hi, we are in the engineering department office, as it's generally called in jargon. This is in fact the department that provides engineering support for the entire process of servicing aircraft. Here we provide direct support for mechanics throughout the entire process of repairs, modifications and other maintenance, where we consult, for example, with external manufacturers on more complicated repair processes, as well as provide the procedures for carrying out specific tasks. The Continuing Airworthiness Management Department assigns these to us.
Okay, so you receive orders here that something broke, something needs to be repaired. You, so to speak, assign who does what, and you write all these, you pass on all these instructions, right?
Yes. Besides that, we also provide support 24 hours a day, 7 days a week, 365 days a year for the entire fleet of aircraft. At LPR, there's one duty engineer who has the emergency phone. And if there were any technical malfunction in Poland somewhere on one of our aircraft, then the pilot calls the duty engineer. He is the first point of contact for him to determine whether the given machine is operational or not, and whether it can continue the mission. Or whether the duty needs to be suspended and, as we say, organize backup to repair the aircraft as quickly as possible.
Okay, I also see here on the monitor your LPR helicopters, right? Here on one side, is this some kind of general, let's say, overview of flights in Poland?
Here on the right side, we have our observer system, where our entire operational situation is shown in real time, how it looks now and where each helicopter is at this moment, what situation is it in.
Is it flying now, as you can see with your professional eye?
As you can see from these lines, yes, you can see that 3 bases are currently on missions. 2 of them, as shown by the red lines here, are rescue missions, and 1 is a transport mission from one hospital to another.
24 hours a day, someone is here managing all of this, and you send this information further so that the helicopters can be serviced down below. Thank you. We're starting the manual work now. Best wishes to you all.
Thanks a lot. Same to you.
You said there are 25 mechanics, but earlier we saw many offices full of people and talked to engineers. So how many people actually work here?
In total, about 850 people work across the entire air ambulance service, okay? So it's quite a large company. Of course, not everyone is based here in Warsaw, because they are also stationed at all those other locations, as well as at all the different bases. Yes, so we have about 120 pilots in our company, and there are around 80 mechanics. And not all of them work here on site. There are also so-called base mechanics who work elsewhere. They work exclusively at one base and take care of the helicopter that is stationed there. Yes, and they are also the first point of contact if any malfunction occurs with that particular helicopter. Then the base mechanic goes there, assesses the situation, let's say, and if any parts need to be delivered from our central warehouse, then a second mechanic goes from here, and together they solve the problem there.
An incredible undertaking. My dear viewers, when you see an LPR helicopter in the sky, think about the fact that almost 1,000 people are working to make sure that those 27 aircraft are in our skies as rarely as possible, but that when they are, they fly smoothly and help people effectively. And also remember that if you want to see some other interesting episodes on the Do Roboty channel, you can send me good leads like that by email. The email address is shown here. It was the same with the LPR. One of the viewers recommended a contact person whom we got in touch with, and that's how we ended up here at the airport base in Warsaw. So thank you very much for all the contacts you send me. Send even more. We're making interesting content especially for you, so give this episode a thumbs up. And now, where are we going next?
To the Composite Repair Workshop.
Okay, let's go.
So we are currently in the Composite Repair Workshop. First of all, as the name suggests, the Composite Repair Workshop is for all kinds of repairs on composites. Our helicopter, the EC-135, is largely made up of composites in its structure. Composite materials can develop defects such as layer delamination, and if we find a defect that requires composite repair, we bring it here to the guys. Here we have a horizontal stabilizer that's currently undergoing such maintenance, and right now the guys are performing a composite repair on it. But not only on composites, but also on metal and aluminum materials, yes.
So you don't just replace these parts, let's say, by buying a new one and putting it in because I see some kind of crack here.
Yes, I mean, mainly we try, first of all, if the manufacturer allows it, we try to repair such a component before we replace it. Here you can clearly see the crack in the firewall because this is the firewall that surrounds the engine, and here most likely a patch will simply be riveted on. And thanks to that, money is actually saved because a whole new component like that costs a lot. And if the manufacturer allows us to make such a repair, then we take advantage of it and we simply make this kind of repair.
But it's great that this video clears up a lot of doubts because people might think the air ambulance service is just pilots. And here, not only do 1,000 people work all together, but there are also various professions that you wouldn't expect to be involved in the air ambulance service, right?
Yeah, exactly. In the end, it's usually the pilots who are on the front pages of newspapers and maybe the rest of the crew after that. But it's also worth remembering, if you ever see an air ambulance helicopter in the sky, or of course our plane from Okenchi, remember that you are part of this too. That we are here too, and in fact we are a strong support to make sure these aircraft can fly and that the crews are safe.
And now we move on to the next stage of this episode. Here we have a historic artifact.
Yes, it's a historic artifact, a piece of the history of the air ambulance service. The Me-Too helicopter, which was actually the predecessor of our HEMS helicopters, not technologically of course, but simply before the era of HEMS in the air ambulance service for many, many years, it was this helicopter that flew and saved patients' lives. The last Me-Too that we retired from service was, I believe, in 2011.
And since when have there been rescue helicopters in Poland at all?
Rescue helicopters, you could say, have been around since, I would say, the 1950s or 1960s, I think, using this helicopter's predecessors. Before that, there was something called medical aviation, right? There were bases scattered around Poland. In the year 2000, all of this started to operate under one umbrella. It went through a kind of rebranding, and for the past 26 years now, we've had the air ambulance service. But it's also worth remembering that part of the history.
Maybe some of the viewers remember those helicopters when they were still flying in our Polish skies. Be sure to write in the comments because this one here looks pretty worn out, but it's quite interesting. Another hangar and more interesting things. Here we are next to what is now a model of an airplane, but this airplane used to fly.
That's right. This airplane was still in service at the technical maintenance station in Okenchi about a year and a half or even 2 years ago. Currently, we use it to train medical crews, right? So now it serves as a model in a real airplane environment. Medical crews can practice performing various medical procedures on a patient here.
But aren't similar ones flying now?
There's still one like this flying and 2 more Learjets.
And here, these smaller planes that we see on my right side, there are 3 of them standing. Those are probably not for transport.
No, these are actually Tecnam P2008s. Some time ago in our air ambulance service, in order to hire new pilots, to recruit pilots, a program was created where pilots could log more flight hours. Because to be a pilot in the air ambulance service, you need to have a total of 1,000 flight hours. As now I might be mistaken as the commander of the aircraft, yes.
So that we don't make a mistake someday, viewers, please write in the comments if you would like to see an episode with air ambulance pilots. Maybe then we can make it happen if there are a lot of comments.
Yes, and for this purpose, the so-called small fleet was created, which consisted of these 3 Tecnam P2008 planes and 2 Robinson R44s, which are in another hangar, so we can also go there and show them.
Okay, so this is where you tested and learned to fly, and I also see a helicopter mock-up here, which we'll come to in a while as well.
Yes, we'll come to it in a while. For now, we won't spoil it for the viewers, but yes, we can already see it, but it will be directly related to a task for you, but that's for later.
So it's worth staying until the end of this video. I know it's long, but Kuba tells such interesting stories that we didn't want to cut too much from this video, so we left almost everything we recorded. So let's move on.
That's right.
The next task is ahead of us.
That's right, we'll be safety wiring the bolts. Safety wiring is one of the basic tasks of an aircraft mechanic. Do you have any idea what it might be for?
Well, so that the bolts or nuts don't come loose.
That's right, exactly. There's no more reliable way to check.
So we'll connect one with the other like this.
Yes, and at this point I do it in such a way that if one screw tries to loosen, it actually tightens the other. So they're basically holding hands.
But you're saying this is the most common task, which is safety wiring, but do you safety wire every screw like this?
Not all of them, but practically all on all rotating elements. Besides safety wiring, I also use cotter pins. And cotter pins and safety wiring are the most common ways to keep bolts and nuts from loosening.
All right, Wojtek, as you saw up there, Adrian gave a textbook example of safety wiring, and we'd also like to check your safety wiring skills.
I haven't done that yet.
Here we have a bypass valve. Of course, it's been taken out of service, marked in red, which means it's no longer fit for use. But we can use it as a mock-up, so you can try to safety wire these two nuts together for us here.
It's always a new experience, yes.
First, we pass it through one loop here. Oh, exactly through this one here. Here? Yes. All right, great. You can let go now. Okay, and now we measure how far we want to go with this wire, and now you can start safety wiring it, twisting. Oh, okay, great. And now we pass this safety wire through this hole here, but this time without securing it. Great, okay. And now you grab this safety wire from this side, grab it here.
Here?
Yes, 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 yes. All right, secure it and safety wire it. Great, all right. And the last thing we need to do is cut off the excess wire here. Here, yes, 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 yes. And at the end, of course, we can secure it by bending it inward.
Sorry, this was my first time using a tool like this for securing wire, so I'm impressed. I think this is mainly done in aviation mechanics.
Well, in automotive work, you rarely see wire locking. In aviation, we use it to secure bolts so they don't come loose.
So I'm not just talking, my friends, and so I can later brag that I really worked on a helicopter. Kuba has prepared a task for us here with a model. What kind of model is this?
That's right. This is a decommissioned helicopter that the Air Ambulance Service purchased. Mainly so that medical crews could train. So here we also have one more task for you today, the last one.
But as we mentioned, you see, there will be a fun fact and there will be a task. So I'll do it here on this unit as well. Yes.
On a real helicopter, a real task. Well, the task is familiar to you because it's safety wiring bolts, only now it's in a real, let's say, maintenance environment on a real unit.
I'm doing the same thing, what I remembered, I'll try to do. Was it good that I cut it off?
Yes, 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 yes.
I'm putting it in now.
That's right. You grab here.
Like this, right here.
Lock it firmly. All right, you can loosen it now, even though this is only Wojtek's second time doing it. All right, all right, all right, or it's gonna snap. Honestly, both I and the guys from the hangar are really impressed with how well he's handling it, because I know that trainees always have the biggest problem with safety wiring when they're learning the trade here in our hangar, but Wojtek is a real professional with a capital P.
So we can confidently move on to the summary of this episode, and there will be one more interesting fact shown and discussed. So stay with us until the very last second of this material and see how it looks. We're nearing the episode's finale, the summary. We'll talk about these two interesting machines in a moment, but dear viewers, if you've made it to the end, I know this episode was very long, but we really didn't want to cut anything out. Please leave a comment saying you made it to the end. If you're watching this show on your TVs, then take out your phone as well and leave a comment under this video on the DoRoboti channel. Now let's move on to these machines. What are they? What kind of helicopters are these?
Just like we talked earlier about the Tecnam airplanes, the three we saw, these are the complement to that small fleet. There are these two beautiful Robinson R-44 Raven II helicopters, which were and still are used for pilot training, and for them as well. I have an aircraft mechanic license, and I also service, repair, and take care of them. That's how it is.
They are impressive. Once again, I ask you, please write a comment if you are here. And now we move on to the grand finale of this episode, which is how much you can earn in this job, what the rates are, what they depend on, and what kind of work we can compare it to.
In our profession, you mainly get paid for responsibility, right? I'll just say in general that the job of an aircraft mechanic is, contrary to appearances, actually a very well-paid profession. Of course, we don't reach the levels of, let's say, pilots, but I can't say that being a mechanic isn't really a good profession where you can actually earn decent and nice money.
Does your pay rate depend solely on a monthly salary, or can you also earn bonuses, for example, for handling difficult repairs? What factors affect it?
It mainly depends on our documents, meaning our qualifications, right? So if we have the B license, then we are paid at the B mechanic rate. And also possibly for any additional tasks, there is extra money. Well, I can say, for example, that because I have qualifications for 2 types of helicopters, I also get some financial reward for being able to service those 2 types, right?
But these are amounts, what, above 10,000 for a really top mechanic who has more of those? I think
that yes, that not only here, but generally in Poland, an aircraft mechanic is able to earn over 10,000 zlotys net.
Great, great. So, my dear friends, you see that this is an interesting profession, a lot of responsibility, a huge amount of responsibility, just looking at what I was doing alone. So let's say safetying those bolts, and secondly, what you said, that every single one of those safeties, by signing, someone confirms they tightened and secured the bolt and are responsible for ensuring it stays tight. So huge respect to you, to the mechanics who keep everything flying from the ground, so much respect. It's great that you made it to the very end of this episode, dear viewers. All I can do is ask you to share this video so it spreads all over the internet, because it's really interesting and the work you do here is amazing. Thumbs up, we won't drag this out any longer. Thank you very much.
Thank you very much.
Thanks to the whole Do Roboty channel community for suggesting such interesting topics.